Thus, if you live at moderate to high altitude, what are some things you can do to partially mitigate some of the downsides? Hello and welcome back. In the previous video I talked about living high and training low and how that does not show a clear performance benefit above and beyond conventional training. I also talked about how living and training high is really only beneficial if you compete at altitude. Moreover, there is a detraining effect which can hurt sea level performance. Thus, if you live at moderate to high altitude, what are some things you can do to partially mitigate some of the downsides, besides trying to grow that extra lung? Number 1, do some of your training, especially your interval sets, on a slight downhill in order to simulate the paces and power outputs that you could do at sea level. This can be done for both the bike and the run. You just have to find a long enough downhill. Now, one of the problems with living in the mountains is there are more hills than flats. The cautionary note here is don't overdo uphill training. More uphill training isn't better. Thus, try to balance hill, flat, and downhill training as much as you can. This study found that running faster on a 5% downhill resulted in the same oxygen cost as running slightly slower on the flat or a lot slower on a 7.5% grade. Thus, you can work your legs at a much higher pace or a higher power output for the same oxygen cost by training on a slight downhill. Number 2, adjust your zone 2 heart rate a little bit higher in order to slightly overcome the loss of pace. I adjust mine about 5 to 10 beats higher for my zone 2. I then adjust my zone a little bit lower for my harder intervals, such as my VO2 max intervals. This is because my max heart rate is lower at altitude. Thus, for the harder intervals, I go by perceived exertion and am less guided by heart rate. Number 3, slightly shorten the length of the interval and increase the rest period. For example, I might do more repeats of 6 to 8 minute race pace efforts instead of the 10 to 12 minute efforts I would do at lower altitude, and I would increase the rest interval. All this so that I can more closely simulate sea level paces. This is true even for sprints. In this study, they found that when they kept the work to rest interval at a ratio of 1 to 3, or in the case of this study, 15-second sprints followed by 45 seconds of recovery, that they could maintain normoxic or sea level power outputs. However, the caveat to the study was that recovery was doing normoxia and they weren't altitude acclimated. Nevertheless, recovery of the ATP creatine phosphate system, which is what is used to power short intervals, is aerobic and just takes longer at altitude. Number 4, lift weights. Resistance training is not negatively impacted by altitude, so have at it. If anything, some adaptations of resistance training might even be aided by altitude. This study found that resistance training under hypoxic conditions increased muscle mass and decreased fat mass more effectively than training in normoxia, although strength gains are about the same under both conditions. The caveat here, though, was that they only trained under hypoxic conditions and did not actually live at altitude. Nevertheless, lifting weights is just a good idea whether you live at altitude or not. This is especially true if you are an older athlete. Number 5, consume a higher carbohydrate diet. First, most athletes tend to underconsume carbohydrates anyway. Carbohydrates are still the best ergogenic aid out there for athletes, but that is a topic I will address in a different video. Nevertheless, due to the slightly higher training stress at altitude, there is an even greater reliance on glycogen. So in order to replenish that glycogen, eat more carb-rich foods. Number 6, along with those carb-rich foods, and preferably together with those carb-rich foods, consume more antioxidant-rich foods. This is important all of the time, but is especially important at altitude as, and I quote, exercise at moderate altitudes is associated with increased production of RONs with reduced antioxidant capacity, leading to oxidative stress, end quote. Now, who exactly is RONs? RONs is reactive oxygen and nitrogen species. These are negatively charged oxygen and nitrogen molecules which can damage tissues. Some oxidative stress is good, it helps with adaptations, but excessive oxidative stress can damage lipids, proteins, and DNA, which may impair cell and immune function, delaying post-exercise recovery. Note the emphasis on antioxidant-rich foods rather than supplements. Use of supplements such as vitamin C have been shown to hurt or attenuate adaptations if taken at the wrong time. But this effect has not been shown for food. This study found that doubling the daily intake of antioxidant-rich foods during a 3-week altitude training camp did not compromise adaptations, but it did elevate plasma antioxidant capacity and attenuated some of the altitude-induced increases in inflammation. Foods that are the most antioxidant-rich are minimally processed plant foods. Plant foods are good too. In this study, they found that plant foods had on average 64 times more antioxidant power than animal foods. Why is that? It's actually quite simple. Animals are nutrient consumers, plants are nutrient producers. Plants make nutrients, animals consume them. Here we see, for example, that iceberg lettuce, the most nutrient-poor leafy green on the planet, has over double the antioxidant power of salmon, eggs, milk, or chicken. The most antioxidant-rich foods, of course, are beans, nuts and seeds, berries, and other colorful fruits and vegetables. When it comes to reducing inflammation, studies show that eating a variety of these foods is more helpful than just eating a few of these foods, likely because they have different nutrient profiles and there is a synergistic effect. This is one reason why consuming nutrients in isolation, such as supplements, is just not as beneficial and in some cases is actually harmful. Not to mention that an added bonus with higher intakes of antioxidant-rich foods is that you will have a higher stool weight for the same fiber intake. So that's always fun. Just be sure to stock up on toilet paper. Now, if you live at a lower altitude and have a race coming up at altitude, what can you do? Well, there's not a whole lot you can do other than train with a sock in your mouth. Okay, I don't think that's actually been studied, so don't try that. But you could try using one of these, something called a PRO2. It's a flow-resistive inspiratory muscle trainer, so it trains your respiratory muscles. I am a little bit skeptical because only a handful of studies have actually evaluated its benefit for acute hypoxic exposure. So in this study, they did find a small improvement in performance at altitude in a 20-kilometer time trial after 6 weeks of training with the PRO2 compared to the placebo group. The best thing is to try to be at altitude for about 1 to 2 weeks right before your event. Conversely, you could sleep in an altitude tent, but you'd have to spend about 14 to 16 hours a day in the tent. Not super fun or easy to do. Although, now that many are just working from home, why not? You could have an altitude office. But tents are expensive and they don't work for everybody. This study looked at the timeline of different performance variables at altitude. Most of the gains were seen within the first 2 weeks at altitude. Here we see the timeline for tests of time to exhaustion, hemoglobin mass, VO2 max, and max power output. After 3 to 4 weeks, you will continue to see small improvements, but 2 weeks is where the most rapid adaptations appear to take place. Something else you can try is plyometric training. Here they found that 4 weeks of plyometric training prior to altitude exposure improved 2-kilometer time trial performance at altitude more so than no plyometric training. Doing plyometric training mixed with resistance training, however, may be even better. In this study, they had 3 groups doing different combinations of plyometric and resistance training. One group did endurance lifting, one did complex training or a combination of heavy resistance and plyometric training in the same session, and the third group did heavy resistance training. All groups also did endurance training. Here's what the complex and strength training look like. The main finding was that doing complex training or heavy resistance training increased strength and power, running economy, 50-meter sprint times, and 5-kilometer performance in well-trained runners. However, the complex training was superior to doing just the heavy resistance training. Now, this wasn't an altitude study. However, anytime you can improve economy, well, that can only be a good thing when you go to altitude because it means you're doing the same work for a lower oxygen cost. In the next video, I will talk about fat adaptation or being fat adapted and whether that is beneficial to endurance performance or not. The answer may surprise you or maybe not.